All right, welcome everyone. This is Steve with Aptera Owners Club. I'm joined by Tim, and Tim is the battery lead engineer at Aptera. Tim, can you kind of introduce yourself? Tell us what your actual position is and what you do at Aptera.
Sure, thank you. Nice to see all of you guys, at least vicariously via this interview. I'm the director of battery and special projects, and what that means is I have overall responsibility for the battery system development and production of the battery system at Aptera. And then, as far as special projects are concerned, we'll branch off into certain areas, maybe interesting solar activities with our solar technology and anything else interesting that comes up that I can participate in. I'm tasked with doing that pretty regularly. So I joined Aptera not long ago. I think it was February. After working with Steve at Flux Power for a while. So some years ago, before Steve started Aptera, he joined us at Flux for a while to help us out, get us out of a pinch, and help me with running production while I focused on engineering there. And he and I exchanged ideas and discussed his passion for this project, this vehicle. And over the years of working, actually, I think it was probably only 2 years working with Steve, I became quite interested in what he was doing and thought it was really exciting. And eventually, he ended up renting some warehouse space from Flux Power and building the the Noir vehicle at our facility. So I got to eavesdrop on that a little bit and get some early
Okay.
glimpses.
So that was like the reboot of Aptera. He was making the Noir
Yeah.
vehicle. So this was in like
Yes.
2018, 2019, that around that time.
Yep.
Is that right?
Yeah.
Okay.
Yes. The years kind of blend together, but pre-COVID.
Yeah, yeah, okay, yeah. So yeah, that's a good way of like kind of keeping the year straight. We
It
definitely
is.
there's like
Yeah.
a interesting timeline there. So yeah, so he was building it there. You guys got to become friends, and then you decided to join Aptera several months ago. What made you
Yes.
decide to join?
Oh, it wasn't the risky nature of a startup. It was it was many of the characteristics of a startup though that piqued my interest. I really enjoy being able to wear a number of hats and exercise a variety of skills and participate in development as well as fabrication and manufacturing activities. So I anticipated that there would be a lot of that, and in fact, there certainly is. But at the same time, I was truly interested in the vehicle. I actually started my awareness of the vehicle was with the first Aptera. A young engineer that I had hired told me one day that he had put $1,000 deposit on this strange looking vehicle. So I looked into it, and at the time I thought, wow, that's not quite for me because I had a pickup truck at the time and I was used to that utility. But what I saw that really interested me is the possibility of having truly phenomenal mileage in a vehicle and not carrying around a lot of excess. And the simplicity and elegance of the early vehicle got me interested in it. So when it started up again, I had already been exposed to it initially, and I thought, oh, this is really strange. I'm working with the guy Steve who had this idea so many years ago that I thought was cool.
Hmm.
Just happened to end up working with him at Flux.
Yeah, yeah. All right, then you had then there was a positioning opening up at Aptera, and then you decided like, hey, this sounds like a good fit.
Right.
So when you joined Aptera, they already had kind of a battery pack designed and engineered, right? Like,
Correct. Yes.
what are the challenges in making a battery pack for the Aptera? And like, how come we don't use like how come we don't use like a battery pack from Toyota or Hyundai or GM or Lucid or Tesla or something like that?
Well, maybe the snide response to that question is because they won't sell it to us, but
Okay.
uh, the reality is maybe a little more subtle. Thankfully, like you said, they had already designed the battery, so much of the heavy lifting was already done by the time I joined. Really, my focus has been on refinements to the design as I've built prototypes. I'm identifying things that can be done in a manner that make it easier to manufacture, more cost effective, and also slight adaptation to a variety of different cell types that we might want to use. So the type of challenges the team faced before I joined, they were really they had to design a battery into a space that is very much different than most automotive batteries. It is kind of a pancake shape, of course, like most of them,
Hmm.
but it's narrower and it has very tight space constraints. So the components, like the power distribution unit, the BMS, the electronics that control it, those have to be placed in a unique position to accommodate the shape of the body surrounding it. So that really sort of paints a picture of a unique battery design that's bespoke to this vehicle. Now, there are companies out there who do make batteries to sell them to people, versus Lucid, for example, they make batteries to sell vehicles and they're not going to share them with other folks unless it's a Formula race car that they happen to
Right.
make batteries for. Companies like Webasto, for example, they make fantastic batteries. They are um, similar in voltage, can be similar in capacity to what we have, but they're specifically designed for industrial applications like buses or heavy equipment. And the packaging efficiency doesn't meet our requirements. Our requirements also involve some level of participation in the crash protection of the vehicle. So the battery is used as a structural element in the vehicle, much like it is in a lot of other vehicles,
Hmm.
structural. But the structural characteristics have to be tailored specifically to the Aptera vehicle in this case.
Mm. I see. I see. Um, so I noticed that in the latest videos of the Aptera, the bus bars, they
Mhm.
look really cool. They're very. I thought they were very elegantly designed as a non-engineer. Was it like that before you joined up, or was that one of the things that you kind of helped refine?
I wish I could take credit for that, but no, the only thing I did was bend them
I
into
see.
that shape. The
Okay.
design was already done. It is a very elegant design. It lends itself quite readily to a very efficient laser welding
Hmm.
system.
Yeah.
Um, that said, we're also pursuing options with wire bonding, which is technology used across the automotive board as well.
Right.
And benefits of wire bonding is that it can afford us some more flexibility in terms of using different cell manufacturers' cells
Mm.
and not having to optimize the process to the specific cell as you would have to do with laser welding.
Okay.
So we're
Are the
working on both in parallel.
are the form factors different between like because they're all 21,700 cells, right? So
Correct.
is it because the like the anode is like a slightly different width or something in different manufacturers, or are you talking about totally different cell chemistries and different form factors?
Well, no, they're all the same chemistry. The cells we're considering at this point are all the same chemistry, but the the cathode shape, which is like the little button at the top of a button cell,
Mm.
those are subtly different from cell to cell, though very subtly. And in fact, it probably wouldn't make any difference. But
Mhm.
on the anode side, because we've opted to connect to the shoulder of the battery as
Yeah,
opposed to say the bottom of the battery for the anode connection, um, the subtle differences in curvature of the anode where they crimp the can together, those really do play an effect, play a big part in how the laser welding has to be tuned.
I
So
see.
it's important also in wire bonding, and that's probably where you see the bulk of difference between cell brands.
Okay, because I noticed like w when there's a video about Peter Rawlinson going through the battery pack for Lucid, and they use wire bonding, which looks like it
Mhm.
would be way more labor intensive or slower. But
It is.
is that not true, or is that true?
No, that's definitely true. I don't know the specifics with any level of certainty, but I think approximately twice as laser welding is twice as fast
I see.
uh, compared to wire bonding, and the equipment is twice as expensive.
Okay.
So if you're doing laser, you need, let's say, one machine versus two machines for wire bonding.
Mhm.
But like any other process in manufacturing, um, you can make a decision about what your manufacturing footprint's going to look like, and that will be swayed in one direction or the other based on other upstream or downstream processes. So
Mm.
there are some upstream processes that might take time for um, adhesives to cure, for example, before the wire bonding or before the lasering. So it could behoove you to have one long line or two short lines. It depends on, like I said, the up and downstream processes. So I wouldn't say there's any real clear winner, but for an organization of our size, the wire bonding technology is more readily adaptable to any changes we might make in our module, whereas the laser welding, you'd want to focus a bunch of time on perfecting it and then ideally not change it.
Right, right. So you guys are working on both platforms kind of simultaneously as a
Yep.
contingency plan in case like the suppliers need to change or something.
Right. And the first three vehicles that we're building now will have each type of bonding technology used in them. So we'll evaluate the differences actually in the vehicles.
Hmm. Okay. So that's something is that's sounds like something that Aptera does often is like they work on multiple different things in the background to have contingency plans in case like plan A doesn't work out. Um,
Yeah. Well,
that's
you kind of have to do that as a startup company. You
right.
have to plan for suppliers maybe making different decisions than you'd been planning on,
Mhm.
or the engineering pointing in one direction this week and a different direction in the next week based on something we learned.
Right. So, because some people get the impression that like, oh, Aptera changed their plans, now they have to start over again. But really, it's a lot of things have been happening in parallel for a long time.
Yeah.
Okay.
Yes.
All right, great. So what it seems like Aptera is using N cooling. Is that correct?
Yes, it is. Yeah.
And why did we
I
decide to go
think,
N cooling rather than side cooling? And what are the like advantages and disadvantages of both?
well, I will speak for the team who's no longer here.
Okay.
And if I were the one making the decision, I would have made the same one.
Okay.
So end cooling is very simple. When you're building a battery, you have to put it on something, um, and it's probably going to be something stiff. And in that case, for automotive, it's probably going to be aluminum. So you've already got a piece of aluminum occupying the bottom of the cells. Um, so a cooling plate isn't a big stretch from there. And they're very cost effective with low development costs. So we can have a traditional sort of dimpled, as you've probably seen the cooling plates in the models. There's
Hmm.
just sort of a dimpled surface brazed up against a flat sheet of aluminum. Whereas the side cooling, the ribbon cooling, like you'd see in a Model S battery, for example, that's very effective, but it requires a fair bit of development effort, and even Tesla struggled quite a lot getting um, the proximity of the ribbon cooling band tight enough to the profile of the cells to have a good interface. There's a secondary challenge with the ribbon cooling in that the cells have anisotropic heat transfer. They transfer heat better axially than they do radially.
Mm.
So that has to do with the fact that they're just sort of like a wound up roll, sort of think like a paper towel roll,
Hmm.
but coils and coils of copper material rolled up with stuff separating them, insulative layers separating them. So they'll readily conduct heat along the length of those copper sheets,
Hmm.
but not so much through the various layers.
That
So
makes sense.
you can pull a lot of heat out from the side, but you need a lot of contact area. and perfecting that effort to get the contact patch broad enough takes a lot of development, and a lot of investment in tooling to make those micro channel extrusions that are used in the Tesla. So it serves us well to use the end cooling. It is in many cases more effective than the ribbon cooling approach or the side cooling.
Mhm.
But I think fundamentally for us, it just fits the nature of early battery development that we don't have to sink a tremendous amount of R&D effort into side cooling. And side cooling is great for very high performance, also like extremely high charge rates or extreme discharge rates. But the Aptera vehicle isn't designed for that. It's designed for very high efficiency.
Mhm. And it seems like, correct me if I'm wrong, that a lot of the other EV manufacturers are moving to end cooling. Like Tesla, I believe, is using end tool cooling. Rivian uses end cooling. I think they stack their cells and they have a plate in the
They
middle
do.
that cools them. And
It's
then
very
looks like
efficient.
Lucid
Yeah.
also does end cooling. So it seems like, is that the way that the industry is moving, seems like?
I think as you see the battery manufacturers or the vehicle manufacturers going to the larger and larger format cells, um, that exacerbates the problem with the side cooling because the as the roll gets bigger, it takes longer and longer for the heat to get out of it radially.
Mhm.
But those big fat cells, they're not appreciably taller than the 21700s.
Mhm.
So the heat transfer axially is still quite good. So I think that's probably why you'd see that shift.
I see. Are you at liberty to tell us about suppliers? Like a couple of years ago, they said that Eve Energy was going to be one of the suppliers for the battery cells. Is that still the case? Or are you guys looking at other suppliers, or
We
you're?
are looking at a we are looking at a few, and I'm not at liberty to tell you which ones. I'm sorry.
Got it. No problem. No problem.